Hello and welcome back to a new video. My name is Eric Macias and today I will be talking about volume, the disk method. Note, for to find the volume of a three-dimensional shape, you you could use different type of methods. There will be the shell method, and in this case we have the disk method. Um, but I would like to focus on just the disk method. So let's get into it. So right here we have two graphs. You can see right here we are focusing on this curve f of x, which goes from A to B. This region right here will be the three-dimensional, or pretty much the shape that is going around the x axis. So we could see right here this is the same curve f of x, but we could see that the whole shape forms kind of like a cone, and the method that we're using involves disks, which is in the same name. Each disk will be part of the shape, but you want to first focus on one disk first of all. You want to know the width and the radius, which is the formula that we will be using. So for this method, we have multiple formulas. We have the pi integral of the radius square dx, and we have pi integral of the radius y squared dy. I would suggest to not use dy, to not use the disk method for dy problems, because you want to use them with the shell method. It's a little bit more complex, but at the same time it helps for equations or problems that you just cannot get it with the disk method. So, but nonetheless it is still possible to get it worked with the disk method. Um, so for this one right here, which we are focusing on the x-axis right here, you can see that it is revolving around the x-axis, and this particular square or rectangular shape right here will be represented as a disk, and that is the dimensions that we want to look for. Same thing over here. You have for the y axis, and it is going revolving around it. So same thing right here, but this time it will be the other way, horizontal. Here we have a vertical, but here horizontal because it's with the y. So you have to memorize that. Y will be horizontal and x will be vertical. Now I have a problem right here for you. The first one says, find the volume of the solid form by revolving the region bounded by the equations y equals to radical of x and y equals x squared about the x-axis. First of all, you want to start with the graph. The graph always helps, so focus mainly on the graph. Once you have the graph, you want to represent the y equals radical of x and y equals x squared right here. This will be y equals x squared, and the green line will be this equation right here. So once you have grabbed that, you will have this region right here, which I highlighted with orange. That's the one that we're looking for. That is the region that we are finding. Now, first you wanna equal the two equations that we have. So as you can see right here, this one is this one, and this one will be right here, x squared. Here, you're gonna have to find the x. So get rid of this radical, get rid of this square, and you will pretty much end up having 2 points, which it will be 0 and 1. Those 2 points are important because you're gonna need them for when you are integrating. Here we apply the formulas. And in this time, we're using the first formula, which was about the x-axis. So remember, in the problem, it says right there x-axis. So they will tell you which one you should use pretty much. So we start with the pi integral of the 2 points, 0 to 1. And then we have radical of x squared dx, which is the same equation, negative, we put the formula again, which is pi integral of 0 to 1, but now x squared, and then put that to square again, dx. So these two equations are pretty much just, it's a minus. So you want to put them together, group them, and you want to solve what is inside. So before you integrate, of course. So you have x minus x and the 4 dx. Now when it comes to integrate, you gotta integrate each. Of course, you integrate each. You have half of x squared minus 1/5 x to the 5. 0 to 1. So in this step right here, you wanna replace the x by the numbers that you have right here, by the 2 points. So you will just switch the x's with these two numbers, but you gotta do it in different, you know, this will be the 0. This x will end up, I'm sorry, this one right here will be the 1. You just replace the 1 with the x. So you end up having this. And the 0, we already know that everything multiplied by 0 will be 0. So the answer for this will be 3/10 pi. Now for the second problem, you have to find the volume of the solid generated by revolving about the y-axis. Now, the region in the first quadrant bounded by y equals x squared, the y-axis, and the line y equals 6. So now this time we don't have two curves. We have one curve and one line. It's a straight line. And we know that is y equals 6. So again, you want to start with the graph, and you want to graph the two equations that you got, which it will be y equals x squared and y equals 6. So as we can see here, we got the green one and the blue one. And the region or the area that you are looking for, which like the volume, is inside those two graphs. So we know that this will be the top equation and this will be the bottom equation. Now, since it was asking you for the y-axis, you wanna have to find the y's. So as we could see right here, is y equals x squared, radical of y equals x, and then we already know that x equals to the radical of y. Then you just want to do the same step that we did in the first problem, which will be putting the formula and just adding the equations that you just got. Now, you should already be comfortable with integrations and stuff like that. So we already know that the answer for this will be 18 pi. You could do the equation on your own if you would like, but those are the basics of finding the volume of a three-dimensional shape.